Good evening. I'm Spot On Weather meteorologist Matthew Euler. Merry Christmas, everybody out there. Thank you again for subscribing to my channel. This, of course, being Christmas night, I hope everybody's having a great holiday. There is some interesting things to talk about in tonight's video for the Teleconnections discussion. Alright, so we're going to start things off like I always do every video each week. And I do want to apologize. I may have to cut this a little shorter tonight. I've been having a heck of a time with these allergies right now. And so, I don't know how long I'll be talking for tonight. But I just want to try and get this weekly video out to everybody. So you can kind of see what's going on lately with the teleconnections. Starting out with the MJO phases and the areas of enhanced convection across the equatorial Pacific Ocean from the dateline west to the African continent. You'll notice that the numbers 1 through 8 appear on this diagram, and each one of these numbers correlates with the various MJO phases and the enhanced convection areas appropriately. Alright, I moved ahead on the MJO temperature composites tonight, and it's just really showing you January, February, and March on the left. Showing you what the, as we get closer to January, for the temperature composites, what the blue shading represents are below normal temps, and what the orange shading represents are above normal temps. So, as we head into January, February, and March, MJO phases 4, 5, and 6, and even 7 are the warmest phases, while phases 8, 1, 2, and 3 are the coldest phases for the eastern U.S. So if you're a winter weather fan or a winter weather person, you definitely want phases 8 through 3 in the months of January, February, and March. Now taking a look at the GFS Ensemble forecast on the right, the green line represents the Ensemble forecast. And you notice the green line in the center of that smaller circle again. You notice it's pretty much remaining in that small circle in the middle of the diagram. Alright, so what we're expecting as a result of that is through the 8th of January, we're expecting an MJO null phase with minimal impacts to the United States temperature regime through the 8th of January. Looking at the GFS Operational MIO Forecast, you'll notice where the aqua color line is, and starting right there in the center of the inner circle, and the forecast goes outward from that center point, showing again more of a null phase for the MJO with minimal impact through the 8th of January. So the MJO is really not going to favor one particular phase. You look at phases 1 through 8 here and where the enhanced convection occurs in the equatorial Pacific, and really, equatorial areas in general, MJO really has been very inactive, just going back to November timeframe, and it's really not moved much. So I'm not really seeing much of an impact to the upcoming temperature forecast, the 10 to 14 day outlook that's caused by the MJO. Moving on to the La Nina update, showing the graphic on the left where the blue shading is. That correlates with below normal water temperatures in the Nino 3.4 region. And the graphic on the right kind of shows where we're at right now. On December 25th, we're looking at about a negative 1.09 degrees Celsius departure from normal in the blue shading in the equatorial eastern Pacific. So it's slightly cooler than the last week. I believe last week's video I was at minus 1.03. So we are seeing some slight cooling once again in the Nino 3.4 region. Now why is that important? Simply put, the stronger the La Nina phase, the greater the impact on the weather across the lower 48 in the U.S. We expect more of a warm, dry winter, especially into January and February with a La Nina pattern if it's strong enough, right? So Right now, La Nina is sitting at a weaker, moderate stage, but it is showing signs of cooling again over the last week. Additionally, on the left, with that the sea surface temperature anomaly map in degrees Celsius on the left, I mentioned blue shading corresponds to cooler than normal water, and then the orange shading corresponds to above normal water temperatures. So from Hawaii on up to off the Pacific Northwest coast, you see that orange shading there, and that's associated with above normal water temperatures. Additionally, up off of the New England states, we have above normal water temperatures as well. All right, so now let's get into the teleconnections. I've been studying these extensively for the last week and a couple weeks, and these are so, these are drivers of the weather, these teleconnections, and they play such a big role in the wintertime across the United States. So let's get into AO first. And we've been situated pretty much for the whole month of December in that negative phase on the left, negative phase AO. And with that, you typically get higher pressure at the higher latitudes, and you get a major dip in the polar front jet stream, where you get the coldest air funneling down from Canada into the lower 48. And we're seeing that. In fact, we're seeing that right now on the 25th of December. We're seeing below normal temperatures. I just stepped outside here, spot on weather. It is really cold out there tonight. I mean, that's a biting wind right now. And we had a very deeply amplified trough move basically from the Midwest to the East Coast over the last 24 hours. We got a major dip in the jet stream, and we're getting a connection all the way up to the high north, up toward the polar regions with this air mass. For example, my dew point recently, just checked it before the video, running at about 13 degrees Fahrenheit right now. 13. Very dry and cold. Temperature is about 30 degrees outside right now. Wind chills are down there too. Yeah, so right now what I'm getting at is this Arctic oscillation, the negative phase, that the graphic on the left, is matching up very well with the current state of affairs in the atmosphere across the eastern U.S. Now the graphic on the right, that's what happens when you get a positive phase AO, and that's where you get lower pressure now at the higher latitudes. You get a stronger polar vortex, and you get more of a west-east highly zonal jet configuration. So that's faster moving systems with a positive phase AO and more of a mild Pacific air mass from coast to coast. So let's look at the forecast here. Now, again, as I mentioned, this doesn't go all the way back to the 1st of December, but the AO has pretty much been negative the whole month of December. Now, will it reach the neutral territory, that zero line there, tomorrow on the 26th of December? Yeah, there's a good possibility it may. But then it drops right back down negative again. Look at that drop off between the 27th of December down through the 28th of December. Dips down to almost -4. Then it kind of comes up a little bit, recovers, and then goes back down again to about -4 around the 1st of January, the New Year's Day. So right now, the European deterministic AO forecast, simply put, cold temps for the eastern U.S. through the 5th of January. What about the European EPS, the Ensemble prediction system, AO 50 perturb members? That green line, like I mentioned every week, is your Ensemble average of all the model runs. And you notice this thing is deeply negative. I mean, all the way through the 9th of January, the AO remains negative throughout. I mean, impressive. Looking at the EPS, the European EPS, AO 50 perturb members out through early February, look how negative it is. I mean, like I said, it's pretty impressive how consistently negative it's been through the month of December. And it plans to stay that way, according to this model, all the way out to 1 February. Looking at the GFS deterministic AO forecast, again, indicating more of a neutral condition right now. Usually the European and GFS deterministics, those models usually line up pretty well in the short term, and this is showing that. Very similar agreement to the European deterministic. Neutral phase, the AO, but then look at that crash again. 27, 28 December, man, that thing tanks down to -4. Yeah, there is some recovery up to about -1 by the 5th of January, but back down deeply negative beyond -4 once again around the 7th of January. So again, negative AO equates to that trough in the east, the cold temperatures across the eastern U.S., and the GFS deterministic says that's the way it's going to stay through the 11th of January. Jeff's V12 30 perturb members on this particular model. Again, that green line, it's negative the whole time through about the 10th of January. All right, now moving on to the North Atlantic Oscillation Forecast, NAO. Positive phase NAO is on the left, and what typically happens with a negative NAO phase on the right. And if you like snow and cold in the eastern U.S., you want that negative NAO phase. You want that blocking into Greenland, and you want that major dip in the polar front jet stream to allow that cold air to come down from Canada into the base of that long wave trough and give you some nice coastal storms back into the cold air. You know, I was looking at Twitter 2 days ago, and it was nothing but like everybody showing these longer range models, European, the GEFS, the global, the GFS Ensemble forecasting system, the GFS Operational, every one of them, Canadian, every one of them was showing the negative NAO phase and that huge Greenland block coming up. And really that hasn't changed, you know, but everybody was just really talking, oh man, I can't wait. This is a great pattern. This is a great pattern for snow on the East Coast. This is a great pattern for cold. It's going to be interesting to see what happens over the coming weeks. But anyway, you look at the left here, that's a positive NAO phase where you get more of a west-east, a flatter zonal jet stream. And you get milder temperatures in the southeast and mid-Atlantic with a positive NAO phase. All right. Here's the actual models for the NAO forecast, European deterministic, showing a positive phase to NAO right now. And that lasts till about the 27th of December. And then that comes crashing down negative. Not sharply negative, to about -1 on the scale. But then it kind of levels off and then dips again down to -2 the first few days of January of the new year. So this is a positive NAO through the 28th of December. That would equate to milder temperatures across the eastern U.S., more of a west to east jet stream, less amplification. Eventually it's falling into negative territory 28 December through 5 January, which that would indicate colder temperatures and blocking in the North Atlantic, that Greenland block, and some possible coastal storm development and closer coastal movement of those storms. The European EPS NAO 50 perturb members, the green line is the average again of the ensembles, all the members. Positive NAO through the 27th of December, then it drops negative, 27th December, all the way through the 9th of January. Next model, European EPS NAO 50 perturb members, 46-day forecast. This runs out to early February, showing the green line there, the average, negative, okay, dropping negative. Temporarily positive around 26 December, then dropping down. GFS deterministic NAO forecast, positive NAO here in the short term through the 27th of December, the next couple days, but then it drops, transitioning to negative through the 27th, from 27th December all the way out through the 11th of January, according to GFS deterministic. And then finally, the NCEP GEFS V12 NAO 30 perturb members. The green line is the ensemble average or mean, showing a positive phase of the NAO through about the 27th to 12 Zulu time frame. That would be early morning time, local time on the East Coast. And then pretty much remaining negative all the way out through 10 January. Now moving on to the PNA forecast. So what have we garnered so far from what I've just gone over for the models, okay, with the teleconnections? Number one, the AO staying negative, right? That would indicate a trough and colder temperatures in the eastern U.S. Number two, we have a positive NAO for a couple days here in the short term, which that would normally indicate more zonal west to east jet stream. Then that's trending negative through end of December through the first 10 days of January. Okay, that's what we determined so far. Moving on to the PNA, Pacific North American forecast, showing again the difference between a positive PNA versus a negative PNA. Now, if you want snow and cold in the east, the mid-Atlantic, you want a positive PNA. Why? Because you get an upper-level ridge and upper-level heights that are rising out in the western U.S., and you get a downstream trough east of the Rockies, Midwest, East Coast, with the heart of the coldest air in that trough. If you want a milder winter here on the East Coast or Southeast Coast, Mid-Atlantic, you want a negative PNA. And that's just the opposite effect, where you get more of a trough, a dip in the jet stream in the western U.S., cold and above normal precip, and then the eastern U.S. you get the ridge that builds in, and you get above average temperatures and drier conditions. You love it. If you want a mild winter, you love negative PNA. So let's take a look at the forecast. All right, so starting off with the European deterministic, we're looking at a positive PNA through about 1 January according to the latest model. And this is going to transition to more neutral conditions from the 1st to the 5th of January. Getting close to the zero line there. It dips down a little bit. It reaches a peak of about positive 2 around basically tomorrow, 26 December, then dips down a little bit. The European EPS PNA 50 per term member 15-day forecast out through the 9th of January shows a positive phase through about New Year's Eve, 31 December, and then more of a neutral condition, basically 31 December. It's really close to that block, the zero line, the neutral line. Maybe slightly positive towards the 7th, 8th, and 9th of January, but overall, 31 December to 9 January is mainly neutral. The PNA now off the European EPS PNA 50 per term members model, out 46 days into the future through about the 7th of February. Look at the green line, the average of all the ensemble members showing a positive phase to the PNA. That would indicate colder than normal temps in the trough in the eastern U.S. through 1 January. Transitioning neutral from 1 to the 20th of January, and that would be more average temperatures, more zonal jet stream, and then negative again after 21 January for the PNA. Negative would put that trough in the western U.S. and the ridge in the east. And then finally, the GFS deterministic PNA forecast, positive up to positive 2 here around Christmas Day and the 26th of December, dipping down to just slightly positive through about 6 January, but you see the transition in neutral ultimately over that period. Then finally, the Ensemble V12 PNA 30 per term members, neutral PNA through 10 January. You see the closeness to that zero line here, so that would indicate more of a zonal jet stream. All right, moving on to the Eastern Pacific Oscillation Forecast (EPO). Now, if you want winter weather in the east, you have to always pay attention to the Pacific Ocean because in the mid-latitudes, between 30 and 60 degrees latitude, you've got to be paying attention to what's upstream, and that comes from the Pacific Ocean. Here's a look at the negative EPO, general characteristics on the left, the positive EPO on the right. Now, if you want it cold and snowy in the east, you are begging and hopefully getting your negative EPO, where you get a high pressure situated over the Gulf of Alaska, and that's positioned north of an area of low pressure just to the east of Hawaii. So you get a high over low situation within a negative EPO. Now you get an upper level ridge in the Gulf of Alaska. What it usually does is it dislodges colder air from Alaska down into the United States, from Canada through the U.S. And so you get more of a trough that develops, with colder temperatures in the east. With a positive EPO, however, now you got a reverse effect in the Eastern Pacific. You get an area of low pressure in the Gulf of Alaska, get the troughing in the Gulf of Alaska, which is going to direct mild Pacific air into western Canada, and generally the jet stream runs west to east from there. And so you get mild Pacific air that's flooding the North American continent, the United States particularly, with a positive EPO. Now notice the higher pressure is more situated on the around Hawaii in this case too, in the Eastern Pacific. So let's look at the forecast. EPO European deterministic, showing mainly neutral conditions from 27 December through the new year, 1 January. But then you notice the white dot, white circled lines there, and how the latest forecast, the 12Z today, shows more of a positive tendency to the EPO. Looking at the European EPS, 50 per term members, look at the green line, neutral conditions through 1 January, transitioning to positive. After that, looking at the European EPS, 50 per term members, slightly positive really throughout, all the way through the 7th of February. And then finally, actually I got this one and another one, GFS deterministic EPO forecast showing neutral EPO, 27 December through 2 January, then transitioning to positive. Finally, look at the Ensemble V12 EPO, 30 per term members, showing a neutral EPO, 27 December through about the 1st of January, and then trending positive again. So, all right. So what does this tell us? Okay. I'll get to that here in a minute. But let's look at the polar vortex. Okay, there's been a lot of talk. If you're a weather fan, a weather aficionado, you are looking at the social media feeds on Twitter probably. And you're seeing a lot of these feeds about the polar vortex. Ooh, this looks good. Looks like it's going to split. Some of these model runs, and this is the GFS. You got to look at all the model runs now, right? You can't just rely on one and wish for that model to come true. Well, yeah, you can. If you're a fan of certain weather, you definitely do that. But you have to look at all the models to make sure that, it's not just one model runs forecasting and the rest are not. And now you're looking at the outlier, right? So with the polar vortex, look at the graphic on the left. That shows today, 25 December, the midday area time frame. Generally shows a concentric polar vortex. Now, the last 3 weeks, the polar vortex has been weakened. Okay, definitely been weakened and stretched and elongated, whatever you want to call it. Now, the graphic on the right shows the polar vortex forecast for the 7th of January. And you'll notice that yellow shading. Now, when we're looking at this particular chart, we're looking way, way high up in the second layer of the atmosphere that's known as the stratosphere. Okay, we're looking pretty far up in altitude, over 100,000 feet above our heads. And you would think to yourself, is my weather really impacted by something that happens 100,000 miles above my head? Yeah, you probably would say no to that. But in all actuality, you can really have some major impacts. It's what's known as a sudden stratospheric warming. See the yellow colors there? The scale and the temperatures is on the right of each of these graphics, by the way. And so the orange and the yellow shading indicates warming of the stratosphere. Now look at the difference between the graphic on the left and the graphic on the right, showing the graphic on the right shows the 7th of January. So you see where we are today on the left, but look at the graphic on the right. You see that yellow coloring really advancing towards the North Pole area, the higher latitudes. This is indicating, the forecast is indicating a sudden stratospheric warming where the temperatures can increase drastically in the stratosphere, way above our heads. And when that happens, sometimes what happens is the polar vortex will split, possibly into two smaller little vortices. So this GFS model is forecasting that to happen in early January. European models have been forecasting similar stuff for quite some time. So what I'm saying tonight in the video is the confidence is increasing for some type of polar vortex split, at a minimum possible displacement, and that could have huge implications on our weather as we head into the month of January. Okay, so my final thoughts on tonight's video as I try to compose myself with all this wonderful allergies I'm experiencing. Like I mentioned, I apologize. I've been pausing more between slides tonight, and I'm just trying to make it through the video, but I am really hopeful that whatever this is, I'll eventually get through the allergies. Ironic, it's winter and I'm dealing with this, but anyway, let's move back into the weather. We're looking at final thoughts for tonight's video. Okay, so first of all, the MJO is in a null phase over the next 2 weeks. Again, with minimal impact, with near average temperatures expected with the MJO. It's not in a cold or warm phase, so we expect near average temperatures. So if we go back here to, again, the graphics on the MJO. All right, let's go back. All right, there it is. And again, I advanced the temperature composites to include January, February, and March. As we're getting closer to January, we're only a week out. And just showing you the favorable cold and warm phases there on the left. And then just showing you the forecast on the right, the GFS Ensemble, as well as the GFS Operational. Look at my lines. They're staying within the green line on this image, staying within the inner circle area, the small circle at the center, not favoring a specific phase right now. So not expecting much of an impact from that. Okay, so MJO next 2 weeks looking pretty minimal as far as impacts. Moving ahead, the La Nina conditions continue across the equatorial eastern Pacific. We're down now to 1.09 degrees Celsius below normal water. In that Nino 3.4 region over the past week, it showed some signs of cooling further. So what we'd expect with the La Nina is more of above average temperatures across the eastern U.S., especially the mid-Atlantic. Dry and warm. Moving on to the Arctic Oscillation, it's negative. All the models are showing it. Continued negative Arctic Oscillation, that would yield below average temperatures and more of a trough or a dip in the jet stream across the eastern U.S. Now the NAO, it looks to be positive in the short term, trending negative. And with that negative trend, we'd expect below average temperatures across the eastern U.S. with a downstream Greenland block in late December, early January. And most of the models are showing this still today. They're very robust on the blocking or the high upper level ridging into Greenland, which could have huge implications in the future here in January. For the Pacific North American pattern PNA, we're looking at neutral conditions, so we expect near average temperatures, the more zonal west to east jet stream from coast to coast in the U.S. with a neutral PNA. The models are also indicating a neutral trend to the EPO in the short term, but it's transitioning to positive. Now that could be interesting, right? It seems almost like the Pacific has not been very active so far this winter. We're in the month of late December now. For the month of December, it just doesn't seem like it's been very active. The Pacific has not been doing a lot. That could change. That could change. The Pacific, got to pay attention to it. That's all I'll say. But with a neutral trend to EPO, we'd have more near average temperatures. But if it transitions to the above normal, positive phase, that's going to equate to above normal temperatures across the eastern U.S. in early January. And let's hope that's not the dominant teleconnection. If you want winter weather in the east, let's hope the EPO and its positive phase is not going to be our one thing that really impacts our ability to have winter weather. And then finally, the polar vortex. The models are indicating that weakening polar vortex and then possibly resulting in a split into two vortices in January. So if you look at the research, if you Google this, you see with a polar vortex split, usually there's a delayed cold temperature reaction. So the cold temps are delayed 2 to 4 weeks usually after the split. So it's not an instantaneous thing is what I'm getting at. So we may not see the impacts of that till mid to late January if it actually does, model verifies, and the full vortex splits. So, and it also depends on how the vortex, once it splits, how it repositions itself. One of the vortices that comes down into Canada is going to favor more of the colder air west of the Mississippi River or east of the Mississippi River. Now, a lot of the research says the eastern U.S. is the one that gets the coldest temperatures with the polar vortex split. But that doesn't always happen. And as an example, I was extremely, being a winter weather person, I was extremely disappointed that in early 2019 with this polar vortex split, everything worked beautifully. We had a split and multiple vortices, and it was frigid in the upper Midwest. We got a little bit colder down here in the Mid-Atlantic, but then the vortex, one of the split vortex, it repositioned itself to directing the cold into the western U.S. The Pacific Northwest and the northern plains got so cold. Montana had one of its coldest winters, as an example, due to that polar vortex split. So just because, majority of the time something happens with the weather doesn't always mean it does. All right, so just keep that in mind. So here's my overall assessment of tonight's video. It's interesting in that we will be looking at a negative AO and NAO. Now this is really interesting to me. All I keep seeing is a negative AO and NAO all the way through early January. That's indicative of a Greenland block situation with a negative NAO and the negative AO with colder temperatures in the east with a trough. Yet some of the latest deterministic models are indicating periods of mild conditions with a flattened zonal west to east jet stream configuration. Go figure. I mean, this is where, I always value learning the stuff because the atmosphere just behaves however it wants to behave. I mean, you have all these rules of thumb sitting here, all these teleconnection rules of thumb, and sometimes they don't even pan out. So I love it. I love figuring it out. It takes me some time, but it's really interesting. Everything looked really solid about 3 days ago for cold and potential coastal, more southern storm tracks in the Gulf and up the East Coast with a negative NAO and a huge Greenland block with a negative AO as well. And you're thinking, oh man, January is going to be one to remember if you want snow cold in the East. And then just in the last couple days, all of a sudden these models are indicating milder and milder conditions, and you're just sitting there like, what in the world is going on here? So this is where I'm going to go to my word of caution. What happens in the Pacific matters, and we have to watch the Eastern Pacific Oscillation, okay? We have to watch that influence on the upcoming 10 to 14 day period. We got to watch it. That could definitely be, the thing that really deflates our expectations with a possible colder and stormier January in the East. That could really be a problem. And what amazes me is watching these low pressure systems on the model runs just kind of develop in the south, but then they work their way northeast up into the Ohio Valley, up into the Midwest again. And that was the predominant storm track we had last year, and it was so mild because the East Coast was always in the warm sector of that storm track. So, and again, those models are hinting at some of that, about more of the tracks taking that turn northeast to the west of the East Coast, and that would be bad news for winter weather lovers. Boy, that'd be bad news. Ooh, I'm hoping that doesn't happen. If you like mild weather, you definitely want that to happen, right? All right, so additionally, we have to watch, in addition to EPO, we have to watch the La Nina. Now, does the trend continue to where these water temperatures continue to cool down even further, resulting in a stronger, moderate La Nina? We're going to have to see. But don't discount La Nina yet. I looked at some of the official outlooks by NOAA, and it's totally a La Nina-based winter forecast. So, we got to watch that. All right? It was weakening. I was optimistic the last couple of weeks because I saw a weakening trend of La Nina, and I'm thinking, okay, good. If it weakens enough, we've had some pretty big snowstorms in the Mid-Atlantic with a weak La Nina. All right? But now it's kind of getting stronger again. Temperatures are dropping again, that Nino 3.4 region. Something to keep an eye on. Additionally, another key player is the PNA, the PNA teleconnection, the Pacific North American pattern. Gotta watch it, because guess what? If this PNA, I'm going to go back to it, if this PNA were to become more positive, you would have a deeper downstream trough. You'd have much colder temperatures in the eastern U.S. But if this PNA eventually goes more negative, now you've got the trough in the west and the ridge in the east, and that would not be good for winter weather fans in the eastern U.S. So you've got to watch that as well, the influence from La Nina and the PNA teleconnection as well. All right, so off tonight's video, what do we get? We have two teleconnections indicating near average temperatures. The MJL is inactive, not much of an impact, and then the neutral PNA. That's more of a west to east jet stream, a less amplified jet stream, faster moving system, west to east across the U.S. And then you got three that are indicating possibly below normal temperatures. What are they? The negative Arctic oscillation, yes. The negative NAO, yes. And then what's the other thing that's causing those below normal temperatures? The possible implications from the polar vortex splitting. Again, that's a delayed time factor, though, on 2 to 4 weeks, on the order of 2 to 4 weeks. And then finally, we have two above normal. That should be above average temperatures. I apologize for the typo. So two of the teleconnections indicating above average temperatures, and they're big ones. They're big ones. La Nina and the Eastern Pacific Oscillation. Those are huge teleconnections, and we're not even factoring the MJL here. But those two right there could really result in a milder January if things fall correctly. So we're cautiously optimistic, if you like winter weather in the east, that the negative AO, the negative NAO, that the highly amplified Greenland block that's forecast to occur, if you want winter weather, you're hoping those are the two predominant teleconnections. You're hoping that's not going to be trumped by a more dominant forcing situation with the La Nina or the Eastern Pacific Oscillation. That's what you're hoping for, right? So right now, based on this breakdown of the numbers tonight, the teleconnections outlooks here in the models, what I'm expecting across the eastern U.S. between now and the 6th to 7th of January, I'm expecting more of an average temperature regime. I really am. And the models are showing this. I'm thinking you're going to get, occasional cold intrusions, but then there's going to be replaced by some milder conditions for a day to 2 days. Overall, it's going to equal out to average temperatures over the long run. If we get those Midwestern systems, that storm track to the west, that's a killer. It'll be mild, and it will be it won't be good if you want winter weather in the East Coast. So we'll have to watch the storm track for sure. And that's all I got for tonight. Hope everybody's enjoyed this video. Thanks again for subscribing to my channel. I hope everybody had a great holiday today on Christmas. And, we're coming up on 2021. We're a week out from the new year. Still a lot to look forward to here in the winter season as these teleconnections battle it out for dominance. All right, that wraps it up. Spot on weather. If we're not spot on, we're not doing it right. Take care. God bless. And most important, stay healthy out there. Take care.